Okay, so in these two questions here, the question that's being asked is to rewrite this so that it has a single base to a single power, is what this is saying. And this kind of example forces you to think backwards a lot of times with the rules of exponents and how we can put these things together. And we know that x to the fifth over x squared times y to the fourth, let's say on the bottom, is simply just x cubed y to the fourth. These bases do not go together, or these values don't go together because they're different bases. The x's can combine to get x to the power 3, but not the y's. And so when I look at these, the question says I want one single base to a power. Well, you have to think about which base am I going to possibly get. And so the only base that's possible, these are special numbers, is to change the 4. I'm just going to rewrite, here's the 4, which is here, to 2 squared. And you have to make the connection that 2 I can get from the 4. And then it's 2 to the y. Using my rules, I get 2 to the 2x. Now, to bring this together, the operation, when it's division, is subtraction. So it's 2 to the y minus 2x. And so I how do I manipulate this 4x to get to a common base with 2? And so now this is a base with a power. In J part, it's the same kind of scenario. I've been asked this question as well. I want a single base. And if I look at 2, 4, and 8, I have to think about they can all be written as 2 to some power. So I know 4 is 2 squared, and 8 is 2 to the power 3. Now I have them all as a base of 2. And so you have to look for connections between them to find a common base. I'm going to simplify this. I know my rules say to multiply those to the 2t. And then this one says multiply 3 times t minus 1. So that's 3t minus 3 because I have to distribute into both. I have common base, so it's 2t. I can add them plus 2t, which t plus 2t is 3t, over 2 to the 3t minus 3. Now I have to subtract them. So it's 2 to the 3t minus 3t minus 3, which is 2. Well, distribute the negative sign. That's 3t minus 3t plus 3, which ends up being 2. Those cancel to the 3, which is 8. But this is probably answering the question best because it wanted some power to one base, or one base to some power. And so in these questions, it's all an exercise of just making the connections to what could be a common base. So if I made up a question that looked like this, let's say 3 to the x times 9 to the 3x over 27 to the 1 minus x, well, if that was my scenario, we should pause it and try it. The common base is 3, so it's 3x times 3 squared to the 3x over 3 cubed to the 1 minus x. And now I all have it as base 3, so 3x times, multiply these, I get 3 to the 6x, divided by 3, and multiply here, it's 3 minus 3x. The top I'm going to add together, so it's 3. I add the exponents when I multiply them. And then 3 to the 3 minus 3x. And finally, I use the properties of subtraction, minus 3 minus 3x, which is 3 to the 7x minus 3 plus 3x. And the algebra says 3 to the 10x minus 3. Now I have a base to a power is what I have there. Hope that helps.